Okay, what I'd like to do today is just take a few minutes and go back over this PHET simulation we used on Friday in building an atom and understanding how these guys work. So I asked you originally to click on the button here, Atom, and we brought up this screen. We see that there are three basic subatomic particles that we talked about on Friday. I'm going to go ahead and check the box here for stable and unstable and go ahead and bring these down so you can see a little bit more. The first question on the sheet that I gave you was just asking you a little bit about protons. And every time I add a proton, you see that something happens. And we see that every time I add a proton, this is changing, okay? But then also this over here is changing. And so what I need you to understand is that every time you add a proton, the identity of the element actually changes. Here I'm adding neutrons, those neutral particles, and it's still carbon. It's still carbon. It's still carbon. Doesn't matter how many neutrons I add, it's always going to be carbon. Same thing with electrons. As I add electrons, it doesn't matter how many electrons that I put up here, this atom is still carbon. However, if I change the number of protons, I see that I end up with a new element. So that's the first takeaway point that I would like for you to understand, is that the number of protons is what identifies an element. For example, any atom that has 6 protons is always going to be carbon. If I take one of those protons away so that now I have 5 protons, 1, 2, 3, 4, 5, now I have boron. And if I take another proton away and now I have 4 protons, now I have beryllium. And so just understanding that the number of protons in an atom determines the name of that element. Okay. Now, let's look at the neutrons and what's going on with those. Pay attention to this top yellow box up here as we go through this, because right now I see that I have 5 protons in the nucleus and I have 6 neutrons in the nucleus. So within this nucleus, how many total particles do I have? 11. 6 plus 5 is 11. And if you look over here, it says that the mass number is 11. If we add another neutron, now we have 7 neutrons and 5 protons, which would give us 12. And so what we need to understand about the mass number is that the mass number is a combination of the protons and the neutrons in the nucleus of an atom. And if you think about what we talked about in terms of mass of those particles, we said that 1 proton weighs 1 atomic mass unit. So every time I add a proton, the mass number is going to go up by 1. Neutrons, we said, also weigh 1 atomic mass unit. Therefore, every time I add a neutron, the mass number is going to go up by 1. And so again, that mass number we have to understand is a combination of the protons and neutrons in the nucleus of the atom. The last thing I want to look at are the electrons. We see that as we add electrons over here, I've got some things changing. Right now we have a neutral atom. And a neutral atom means that it's not positive or negative. We understand that every single one of these plus signs represents a proton. So if we look up here, we see that we have 7 protons, we have 7 plus signs. We look down here at the electrons, there are 7 electrons, there's 7 negative signs. And so each one of those positive and negatives cancel each other out. But what happens if I add another electron? So now I have 8 electrons. You see here that I have an extra electron, which is why I have a -1 charge. If I were to add another electron, now I have 2 extra negative charges. Yes, Cohen, I'm downstairs. Now I have 2 negative electrons giving me an overall charge of -2. Okay, what happens if I bring out those electrons? It's neutral again. 7 protons, 7 electrons. What happens if we take away, well, let's add a proton. Now we've added a proton, okay?
Mom, there's something not going right.
I'll deal with it in a minute, going. So now I have an extra proton here, which is why now we see that +1 charge there. And so the key thing to understand about the electrons in an atom is that the electrons determine the charge of an atom. If you have more protons than electrons, then you have a positively charged ion. If you have more electrons than protons, so you see right here we have an extra electron. If you have more electrons, then it's going to be a negatively charged atom. And that's the key thing to understand about those three particles at this point and how they depend upon each other and what roles they play in the atom.